Yo, good day guys. I am Lhansen M Guzman from BSed Math 2B, and today we're going to answer the question number 47. Consider the matrix A is equal to 1, K, 2, and negative 3, 4, 1, where 1, K, 2 is the row 1 and negative 3, 4, 1 is the row 2. If A is the augmented matrix of a system of a linear equation, determine the number of equations and the number of variables. So since the number of rows in the matrix corresponds to the number of equations of the system, we will have two equations. Because here we have two rows where R1 is 1K2 and R2 is negative 3, 4, 1. So two rows is equal to two equations. And the number of variables is equal to 1 less than the number of the columns. So we will have two variables. B. If A is the augmented matrix of a system of linear equations, find the values of K such that system is consistent. Using Gaussian elimination produces the following. The goal here is to turn the negative 3 into 0. We can make it by multiplying 3 into the first row. So R2 plus 3R1 is our new second row. Because 3 times 1 is equal to 3. 3 times K is equal to 3K. And 3 times 2 is equal to 6. And at this point, the negative 3 will turn into 0. After this, make 3K plus 4 into 1 as a part of the main diagonal. So by multiplying 1 over 3K plus 4 into the second row, we can make it. So 1K, 2 is a row 1, and 0, 1, and 7 over 3K plus 4 is our new second row. 3K plus 4 is not equal to 0 since it's the denominator. Solving for K where K is 3K plus 4 is not equal to 0, we will get K is not equal to negative 4 thirds. So the system is consistent if 3K plus 4 is not equal to 0 or K is not equal to negative 4 thirds. If A is the coefficient matrix of homogeneous system of linear equation, determine the number of equation and number of variables. Same in letter A, the number of rows is equivalent to number of equation, so we will have two equations. And the number of columns is equal to the number of variables, so we have 3 variables. If A is the coefficient matrix of a homogeneous system of linear equations, find the values of K such that system is consistent. As like what we did in letter B, we have repeated the process, but here we include the zero constant of each equation, and the result is also the same. We get K is not equal to negative 4 thirds. Notice that K is not equal to negative 4 thirds, but what if we substitute it for K in the original matrix? It will result 1, negative 4 thirds, 2, 0 for the first row, and negative 3, 4, 1, 0 for the second row. And then perform R2 plus 3R1 to get the second row. Here, it simply shows that the system is consistent. So the original system is consistent for all real K.